Hi, we are Group H, and I'm Matab. I'm joined by Ahmed, Meng, Kaylin, and June, and we're going to be going over Cubs Den. I'm going to pass it to June for the introduction.
Thank you, Mata. What are the issues and challenges? Extracurricular activities are essential for personal growth, networking, and leadership, yet many students face barriers. With over 400 clubs at the University of Alberta, the absence of options can feel overwhelming, particularly for the first-time joiners unsure where to start. Communication from club is scattered across the platform, such as Instagram, emails, and posters, making it difficult for students to navigate the system. The fragmentation results in about one-third of students not participating in extracurriculars, causing them to miss opportunity to connect and grow. Now we move on to why existing platforms fail. The current tool for club engagement, like Bearsden, are falling short. Its outdated interface and lack of user-friendly features lead many students and club leaders to avoid it altogether. As a result, club turns to scattered platforms like Instagram and emails to promote events, creating fragmented systems that confuses students and leads to missed opportunities. The disjointed process overwhelms students and discourages participation, while club struggles to attract and retain members. An, a unified, accessible solution is clearly needed to bridge the gap between students and clubs. Now I'll be talking about fragmented system creates challenges for both students and clubs. For students, scattered information leads to decision fatigue, mismatches, and disengagement, causing them to miss opportunities for growth and connection. Club struggles with disengaged members, high turnover, and inefficient event promotion, limiting their ability to grow and attract new members. These challenges reduce the value of extracurricular activities, emphasizing the need of a better system to support both groups. I'll be talking about why engagement matters. Extracurriculars activities are essential for enriching the university experience, benefiting for both students and clubs. For students, joining clubs improves retention, academic performance, and critical skills such as teamwork and leadership. It also fosters sense of belonging and support mental well-being. For clubs, stronger engagement improves member retention, streamlines events promotion, and drives overall success. A centralized system like Clubs then can bridge these gaps, ensuring the thriving and connected campus community where both students and clubs benefit. Now I'll be talking about the proposed solution for our project. Our proposed solution is Clubs Den, a centralized platform integrated into exiting My U Alberta app. Clubs Den simplifies how students discover and engage with extracurricular activities by centralizing all club information into one easy-to-use platform. Its AI-powered recommendation engine personalizes the experience, matching students to clubs and events based on their interest and past participation. Real-time updates and notification ensure students to stay informed about the events, changes, and reminder, making them easier to stay connected. For clubs, Club then streamline operation with tools like RSVP tracking, allowing better member management and event planning. While its user-friendly design and advanced feature, Clubs then creates a stronger connection between students and clubs, fostering a more engaging and inclusive campus community. Now I'll pass it on to Ahmed for the next slide.
Thank you so much, June. We'll be talking about data flow and use case for Cubs Den data flow diagrams and then the use case descriptions. Um, the context diagram provides a high-level overview of Cubs Den system and its interactions with external actors like students, clubs, and university systems. This diagram outlines how data flows into and out of the system, such as searching queries, recommendations, event details, and authentication data. It serves as the foundation for understanding the overall system design. Now moving on to the level 0 data flow diagram. This breaks down the system into 5 primary processes: managing club and events, searching and filtering club events, providing AI recommendations, managing RSVPs and notifications, and then finally authenticating users. This diagram highlights how data is exchanged between these processes, the actors, and the internal database to deliver the system functionality. Next, we're going to be looking at the level 1 through 3. We zoom into the specific processes. For example, the managing clubs and events diagram, it decomposes tasks like creating and updating clubs profiles and events. Moving on to the next level, so level 2, that's going to be the search and filter club events diagram, which explains how search queries are processed. And then moving on to level 3, that's going to be while the provide AI recommendations diagram illustrates how the user preferences and engagement trends are used to generate personalized suggestions. These detailed views highlight how Cubsden handles user requests and user requests efficiently. Now moving on to level 4 and 5 diagrams, we dive into manage RSVPs and notifications and authenticate users. The RSVP diagram shows how students confirm attendance and notifications are sent. Moving on to level 5, the authentication diagram highlights secured credential validation through the university system, while also ensuring both accessibility and security. These processes ensure reliable and seamless user interactions with Cubsden. Moving on to the use case diagram, it provides a user-centered perspective of Cubsden. It identifies key functionalities such as searching for events, RSVPing, joining groups, and managing clubs. Club profiles, I guess. The diagram also emphasizes the interactions between students, club leaders, and the university system. Moving on to the detailed use case description, further explains how Cubsden major features operate. For example, students can search for events by entering keywords, RSVP for activities, or join groups they're interested in. Each use case is described with preconditions, steps, and outcomes, ensuring all processes align with user needs and system objectives. Now moving on to Mahtab, he will be going through this part.
Thank you, Ahmed. I'm going to be covering some more diagrams, including the activity diagram, the conceptual model, and the state machine diagram. So let's look at the Cubsden's activity diagram. As shown, the system consists of 5 major roles: the student, the club leader, the university admin, the IT department, and the Cubsden system itself. The student's role is to log into MyUAlberta, which initiates the process. Once they're logged in and the Cubsden system has authenticated this, they can browse clubs, RSVP to events, and they can receive notifications. The club leader can also initialize the process by logging into the Cubsden system. Once their login has been authenticated, they can create or alter existing events, manage RSVPs, send notifications, and analyze club engagement. The university admin is in charge of overseeing the way Cubsden is governed. They can approve and review club activities, and they can provide support in the management of Cubsden. The IT department's role consists of managing system integration, so how the system goes about completing its tasks, as well as monitoring system performance and ensuring security of private data. The Cubsden system itself must authenticate logins to ensure process initiation, and it also gives clubs recommendations through the use of AI. It also sends notifications and updates RSVP status. Now let's look at the conceptual model. This is Cubsden's conceptual model. We can see 5 entities, which are event, club, student, RSVP, notification, and AI recommendation. These 5 entities are how data is contained and passed throughout the Cubsden system. Now let's look at the state machine diagram. Cubsden's state machine diagram consists of 6 states, a start and an end. These states are idle, event selected, RSVP initiated, RSVP confirmed, viewing recommendation, and notification sent. When the system is idle, it is waiting for input as the student has not logged in or initiated any RSVP. Once the student logs in, Cubs then provides them with personalized recommendations, including different clubs to join and events to RSVP to. When a student selects one of these events to RSVP to, the system enters the event selected state. Then, if the student wishes to send an event RSVP, the system goes into the RSVP initiated stage. When this RSVP is confirmed by the club leader, the system is in the RSVP confirmation state. This means that the RSVP has successfully been completed. The system then sends a confirmation notification email to the student, and this ends the process. I will now hand it over to Meng, who's going to showcase the website's mockup.
Thank you. So here we have 4 separate screenshots from the mockable website. We have the homepage, the About section, which introduces CubDen. We have the services and the AI Club recommendation form. Now I will go to the website. Yeah, so as previously mentioned, here we have the homepage where we can view the services provided. Here we have the About section, which introduces CubDen. And if we go back down to the services, if we click on the club profiles, it shows a mock-up of 3 separate clubs at the U of A, including the BSA, Sphere, and UAIC. Each club will have the president, the club mission, club goals, and upcoming events. Next, if we go to upcoming events, it will show a list of all the events for the week. The user can filter it either by the clubs they're interested in or just show all the events that are happening on campus. Next, if we go to calendar, it will have a dynamic calendar that shows all the clubs you're in, or it can also show the clubs you're interested in, as well as all the events that are occurring. Lastly, for the AI recommendation tab, you can input your information, and they ask you questions such as what type of clubs you're interested in, what do you want out of a club, what are some of your hobbies and interests, what activity interests you the most, what main interest areas you want to explore, and such. And after you submit it, the AI engine will give you a list of clubs that will interest you. And lastly, there are other features such as a search function and an FAQ for those who want more information. Here we just have more screenshots of the mockup. Now I'll pass it on to Kalan.
Awesome. Thank you, man. Yeah, so getting further into the detailed design specifics, I'll walk you through the detailed design of CubsDen, which is designed to enhance the student engagement and streamline club management at the University of Alberta. We'll explore 3 key diagrams that showcase how CubsDen is structured and how it aligns with our goal of creating an accessible and effective tool for students and clubs. The 3 diagrams we will be showcasing are the logical data model, physical architecture diagram, and then lastly, the class diagram. Following that, we're briefly going to talk about some of the outcomes and the ramifications of using these visualizations in the CubsDen process. So firstly, let's start off with the logical data model. This diagram is the foundation of CubsDen, defining the key entities, their attributes, and the relationships that are interwoven between them. For this example, we have entities like the student, club, event, recommendation engine, and a few more that work closely with one another in the system. Each one of these entities is tailored to support the CubsDen's unique functionality. For instance, the student entity includes attributes such as student ID, contact information, and preferences, enabling personalization beyond any other thing that the university can offer. Additionally, the club entity holds data about club names, descriptions, and leadership, supporting efficient organization and search functionality. And although we won't be exploring the data model in detail, it is apparent that the logical data model is a visualization of the backbone and foundation of the system. This model is critical for creating a structured, normalized database that ensures efficient data retrieval and scalability as the platform inevitably grows. Let's continue forward towards the physical architecture diagram. This high-level diagram outlines the major physical components of CubsDen, divided into layers such as applications, services, software, hardware, networking, and lastly, data centers. Each one of these layers and their respective components uniquely support CubsDen as a whole. To get a better understanding of this, we will go through each one of them. In the applications layer, CubsDen integrates directly into the MyUAlberta app, ensuring students have access without downloading a new platform. Additionally, the CubsDen system will also be available for access through a website easily accessible through the browser. The services layer includes features like the recommendation engine and analytical tools, which provide AI-driven personalization and data insights. Moreover, the system will act as a hub for all university clubs, notifying users through the use of the aforementioned AI-driven recommendation engines. The software layer covers CubsDen's core software functionality, including data storage and management, such as SQL, the robust AI recommendation engine, and the presentation of user interfaces. Then moving on to the other half of the diagram, the hardware layer, the system supports a variety of devices, including smartphones, tablets, and computers, while servers handle back-end processing. The network layer ensures reliable communication between components, utilizing the locally connected university networks, the internet, and other network security components. Lastly, the data centers for CubsDen will include both physical and cloud-based data centers. These will be used to store various amounts of data, enhancing the AI recommendation engine for users. And then lastly, now that we have a better understanding of the physical architecture of CubsDen, we're going to continue on to our last model called the class diagram. So the class diagram, bridging the gap between design and development, takes the logical entities from the data model, which we previously had covered, and transforms them into a software class, adding behaviors or functions to each of them. So in a sense, the class diagram is fairly similar to the logical model diagram. Let's take a closer look at the model for an example. The student class includes methods like update preferences for personalized recommendations, keeping the relevant attributes that we can see in the logical data model. The function of the student class can be seen in create user, club signup, and a few others. Again, the event class features similar attributes to the previously mentioned model. However, methods like add RSVP and update details are displayed. These functions are primarily for simplifying event management and club activity. The recommendation engine class drives CubsDen's AI-powered suggestions through methods like generate recommendations. Taking a more intuitive approach, you can actually see how this happens. You can see that within that class, we are using student IDs, specific analytic IDs, and club IDs to tailor the club recommendation uniquely to the user. So in a broader scope, this diagram serves as a blueprint for developers, ensuring that CubsDen's software aligns with its intended functionality. And now moving into the ramifications, acting as the backbone of the service CubsDen intends to provide the students of University of Alberta, the various models provide a comprehensive framework for the system development process. And in following this, it ensures the delivery of a smooth, accurate, functional, and efficient system that correctly meets the goals set out for CubsDen. Thank you again for watching our presentation, and we hope you enjoyed.